Hi, this is Sarah Humphrey doing number 7 of test 1. So I'm going to start with drawing north 37.5 degrees east. So let's see, that would be about the 45-degree line, so I'm going to draw something close to that. It doesn't have to be perfect. And this goes on for about 8.25 miles. Okay, so this angle is the 37.5 degrees. Now that was the first hour, the 8.25 miles. Then the wind changes to 6.0 miles per hour for 1.5 hours. So we're going to put 6 times 1.5 equals 9 miles. So this angle, wherever we draw it next, is going to go for 9 miles. So the question asks for south of 52.5 degrees east. So what I'm going to do is I'm going to draw little dotted lines, make pretend axes, and then let's see, southeast, right, 52.5 degrees. So I would probably put that at about there. And again, this line goes on for, let's say that's 9 miles. So now we have our sort of line from the starting point to there, just so we can visualize it. So for the first start of the problem, it's asking what is the bearing of the balloon from the starting point. So that is 37.5 degrees, which would mean that this little angle is 37.5 degrees, and would tell me, from us knowing that south 52.5 degrees east would be 52.5 degrees, I'm going to add 37.5 plus 52.5, sorry for my handwriting, is 90 degrees. So now I know that that angle is 90 degrees, which tells me that, hold on a moment, the bearing of the balloon from its starting point, we are trying to find this angle right there in that corner. From this, where we started, all the way to pointing to there. So I'm going to have to find, from knowing this is 90 degrees and knowing the side lengths of these two sides, I'm going to have to find what this is. And I'm going to do that through tangent. So let's set up the problem. Tangent of theta would be opposite over adjacent, right? So we're trying to find this one right now. We're not trying to find the entire answer, because we already know that this part is 37.5 degrees, so we just need to find this half of it. So tangent, opposite over adjacent, that would be, what, 9 over 8.25. So let's write that over again. Tangent of theta equals, put that into a calculator, 1.0999. Now, if I multiply both sides by the inverse of tangent, I'm going to get us to theta equals tangent inverse of 1.0999. And when I do that in my calculator, I get theta equals 47.48 degrees. So now we know that this angle is 47.48. So we're going to take this and we're going to add it to this, so we get the bearing of the balloon from the starting point. So let's put it here, 47.48 degrees plus the initial 37.5 degrees brings us to 85.0 degrees. So that's the answer to part A. Now, part B. At that moment, when it's all the way over here, what is the distance of the balloon from its starting point? Okay, so that one's easier. That's just me using the Pythagorean theorem to find the hypotenuse length. So, Pythagorean theorem states a squared plus b squared equals c squared. Now let's say a squared is 8.25 and b squared will be 9. So let's square them both. 8.25 squared plus 9 squared equals c squared again. Let's bring that over. Now we have, put that into a calculator, 68.0625 plus 81 equals c squared. And when I do this math, I get c squared is equal to 149.0625. Now, what I'm going to do to this now, let's see in the pink pen. Since this is equivalent to c squared, I'm going to find the root of that. So when I use my calculator and I find the root of that, I get 12.2091155, whatever, right? This is the number of miles that this is, so the length of the hypotenuse side. So I would, let's see, round your answer to 2 decimal places. Okay, so I would put 12.21 miles. So, in conclusion, the answer to part A of number 7 is 85 degrees, and the answer to part B of number 7 is 12.21 degrees.